Hello everyone, this is Neeraj Shukla here and we are welcoming you to yet another training course related to data center design. I know that you are waiting for this course for a long time. Well, this particular topic, that is data center design, is very hot topic these days because everyone is talking about the data centers. Everyone wants to come to India and set up their data center design. So there are a lot of curiosity about data centers, though it's not a new subject. This subject was prevailing long back, but now the curiosity and the need is higher than ever. So sooner or later, you or your company is definitely going to have this data center project, and for that, you need to be prepared with all the answers, should be ready and fully equipped with all the solutions. If any project comes, you should know everything about data center, then only you can make a difference in your career and profession and your job. So I really sincerely thank all of you and welcome all of you to choose this particular topic of data center design. This shows your desire to learn and prosper more in your profession. So without wasting too much time, let's move ahead and let us explore more on it.
Well, before commencing for the course, well, all you must know about the trainer, that is me. Yeah, see, as you know, my name is Neeraj Shukla. I have total 22 years of professional experience in the field of HVAC. I am an international HVAC consultant. I have given my consultancies to various big organizations all over the world. I have worked with Fortune 500 companies and I have worldwide experience on project execution. I'm an author of 3 books. I'm a director of 3 companies. I have proven skill set which I've acquired through my knowledge and experience, whatever I've gained and learned so far. Then I'm an international motivation speaker, and this is my passion to offer mentorship to all MEP professionals. So if you are on LinkedIn, you might have observed that we take a lot of efforts in giving directions to MEP professionals so that they should learn and grow, because I have experienced that there is no proper guidance available on online platform. We have seen Facebook and YouTube videos also related to HVAC, but there are a lot of mistakes in videos. So sometimes we used to feel sad. And then when I used to sit with my team and used to discuss with my mentors, an idea came that no, a proper guidance must be given through a professional person like me, and like-minded people came together. So on a LinkedIn we have tried it, on Facebook we have tried, then on YouTube it is there. So this is how we are exploring and increasing our mission to train and upskill the MEP professional so that they can grow in career, as well as it should benefit a community and a nation also. So this is how it is. So now let's move to the main course. Why we have chosen this topic of a data center? Yes, I will explain you. Data center is now buzzword everywhere. It is recorded as the fastest growing sector in MEP in India. It has a tremendous growth potential in future due to data explosion. I mean, this is not new. This is what we all know. The rate at which the data we are acquiring, the rate at which the data is happening, we are collecting, we are sending, it is going to be a huge demand in future. Already that demand has started reflecting. You might have heard in your company everywhere that data center projects are likely to coming. You might be bidding for data center project. So this is a definitely need of an hour. And there are not many, at least I have not heard any company or any private institute is conducting the course of data center design. So this is very important that some proper guidance must be there. So this the course is all about it. There's a lack of skilled resources. We all know. Just now I clarified that there are no resources available properly to guide. Then to create awareness and skilled manpower. So moment you do the course, moment you start implementing it, will be skilled at it, so definitely the awareness will be created. This is what we want all about, a proper guidance along with the proper awareness, and add value towards the industry. By getting upskilled, definitely you will implement in your work while quoting it, while designing it. As you can see that we have given the proper live example also of proper live case study of data center. If you implement, if you do it properly, definitely it is going to add value to the industry. So certainly this course is going to help you in a big way. So this is why we have chosen this topic of a data center. Well, let's understand what is this data center. Data center is a building or dedicated space within a building or group of buildings which houses computer systems and associated components such as telecommunication and storage systems and server. Data center and telecommunication facilities are significantly different than most of the other facilities. Why? I'll just explain one by one. Firstly, the occupants of most facilities are people. It may be office, it may be restaurant, it may be school, it may be hospital. You see, the facilities are defined or they're constructed for the people. The occupants in data centers are computer hardware and software applications. There are no occupants in data center. Occupants only come for maintenance purpose or checking purpose, that's it. Otherwise, occupancy in data center is almost zero. Second thing is load is more volatile and transient because of the hardware upgrades, software additions, and computing loads change and can vary so rapidly. If you see, the operations are so drastically different here for different times. Say in the night, maybe operations may not be there. So maybe the load may be low there, but in the morning, of course, all computers are working all over the world, so data is getting gathered, software upgrades are happening, hardware upgrades are happening. So definitely load is more and more volatile and constantly changing in data centers. As against the normal comfort applications for humans, the load pattern is more or less fixed. Suppose for example in office, people are coming at 8 o'clock, going at 6 o'clock, so more or less 8 to 6 the pattern is fixed. After 6 o'clock, suddenly there's a drastic change. People are going to office, AC is not required. But here it is not the case. The load is always in fluctuating mode. So this is the main difference also between the normal HVAC and a data center HVAC, that load fluctuation is different as compared to the normal comfort applications. Thirdly, the computer hardware is a major equipment, and equipment lifetime are often measured in months rather than years. The result is upgrade or life cycle mismatch between the hardware and facility power cooling. Say for example, due to frequent load fluctuations, it affects the hardware also, its operation also. You have to constantly change it, or definitely it affects the life cycle of a machine, and ultimately it affects the cooling cycle also, or the cooling requirement also. So while designing also we need to consider this diversity factor or whatever in mind. And lastly, often data centers have an actual power cooling load density 10 times more than normal typical office buildings. So if you see, the heat emitting equipment in data center are much higher as compared to office. There's a server, there's a rack, a lot of computer operations are happening inside. So definitely it is resulting in emission of heat. So it has to be counted. That's why it is said that normally it is 10 times higher than the office buildings. So this itself is a big factor to be considered while designing data centers.
Well, let's have a quick look over here how the data center works. It's a very interesting video we have picked up from internet. It will be very useful for you to see this video to quickly understand how the data center works. So let's explore it here.
A Google search, a YouTube video, a connected Nest device, and hundreds of Google Cloud services all give you a response in a fraction of a second. But what really happens when you click search, send a request, or say, OK Google? Well, your message travels over the public internet and into Google's global fiber network. Millions of these requests or packets of data travel through miles of cable over land and undersea, converging at one of the many data centers we operate all over the world. But besides delivering quick results back to you, what exactly is a data center? A data center is a building with powerful computers used to run a company's services. It's where information is processed and made available. Data is stored, managed, and disseminated across these computers. And network infrastructure is installed to support web apps, databases, virtual machines, and more. Often, organizations start with their own modest buildings, made up of a few server racks, which requires maintaining these systems, paying for cooling, and handling increasing demand. So, many companies look to a cloud services provider like Google Cloud. These providers' data centers have evolved into large campuses of multiple buildings. Hyperscale data centers, made up of tens of thousands of servers, process big data, support cloud computing, and serve billions of users for services like Chrome, Maps, Gmail, Search, and Google Cloud. In the cloud world, companies and users can benefit from this scale because of a special thing called multi-tenancy. This means customers can share the resources of each server in a data center, like tenants sharing common resources of an apartment building. Each tenant's cloud systems are isolated and invisible to other tenants. This means higher compute processing and storage, a more efficient use of data center resources, and a much lower cost than if you manage your own servers. Google Cloud customers can even deploy resources in regions across the world, which are enterprise data center locations with 3 or more zones. Zones are deployment areas that map to clusters of machines with distinct physical infrastructure. Companies can deploy workloads across multiple zones to help protect against unexpected failures, something you can't always get with a single private data center. It takes the right mix of energy, cooling, and people to keep a data center up and running. But it's a technical feat Google's managed to pull off to optimize for efficiency, scale, and cost. More on that next time on Discovering Data Centers.
The main requirement of datacom facilities are space, power, cooling, and networking. These are the main requirements of any data center. Often these are treated as services. Well, because of the high capital cost and short life cycle of the datacom equipment, as well as the continued evaluation of both public and private cloud computing, the trend is toward the companies owning less or own data center facilities and renting and leasing services and facilities in many verticals. What I mean to say that instead of owning a data center, companies are leasing or renting a data center. So there are many private players who are acting as they're housing the servers of big companies in their premises and they're charging a rent for it. This is a very common trend nowadays. So you may see in future that there are many private players coming into the picture and they are renting their space like an ATM. You see an ATM, right? The ICICI Bank or any big bank, they don't own the ATM space. They just rent it up. They just take it on rent, and they just keep their ATM machine there. Similarly, all these big companies also in coming few years or coming few days, they've already started this trend to house their racks or servers in a rented space. And there'll be a maintenance company who will be taking care of all the maintenance of a server, or in-house person will be there who will be taking care of it. So these are the basic requirement of any data center. The functions are several, like physical security has to be there for data center because there's a lot of data is very important factor. So there has to be a physical security for data center. There has to be a temperature control because if a temperature goes high or low, it affects the operations of a server. The humidity control has to be there. Again, it affects a major factor for the data center, server or racks. The operations are very critical. The centralized location is very important because in case of anything happens, it should be easily accessible. Then electricity, as you know, it's inevitable. Any data center needs electricity. So easy access to electricity has to be there. You might be knowing that all the data centers are, along with the normal electricity, they're equipped with a generator. So in case of major power failure, the generator turns on and all other services which are required, it may be UPS, it may be cooling, it may be lighting, all goes without uninterrupted within the data center. So a generator is a mandatory requirement for any data center. So while designing, you should take note of it. You may ask client that where is the generator? Why the generator has not to be considered. So while quoting, you should quote for the generator also. If client is not taking care of it, you should tell him in a meeting that where is the generator. Definitely it will impress your client that you know about the data centers. And convenience support is also very important. So if something happens, the team should be there to take care of data centers. The maintenance aspect point of view, the team should be multi-skilled. It's not that I know only this, I know. No, they should know something of everything or everything of everything. So this is how the major functions of data center should be. As we all have seen that the services for data centers, mostly the space, power, cooling and networking. What does it mean? First, the space is needed to mount your racks, mount your servers properly. Second is, of course, the power is needed. That without power, how your servers and how your cooling is going to happen. Third is, of course, the cooling to maintain the required condition for the safer working of the racks and servers as per the manufacturing recommendations. And fourth is networking. Of course, the word says everything. So these are the factors are shown in this photo also, this picture also, image is self-explanatory. That how the data center looks, how the data center requirement goes. So it is self-explanatory that how it should be. Now let's move to the main section, the resources for data center design. This data center design itself is a huge ocean of a subject. The ASHRAE has come into picture and they have released around 13 books and several standards which can be picked up for the complete data center design, right from the cooling to the building construction to the thermal designing, structural vibration guidelines to everything. Let's move and have a sneak peek of each book one by one. Say first one, the Thermal Guidelines for Data Processing Environment 4th edition, ASHRAE 2015A. This particular book provides a framework to align the goals of equipment hardware manufacturer, facility designer, operators and managers. This book covers the four primary areas: the equipment operating environment specification, facilities temperature and humidity measurement, equipment placement, airflow patterns, and equipment manufacturers heat load and airflow requirement reporting. Now let's move to the second book, that is IT Equipment Powertrains 3rd edition, ASHRAE 2018. Well, it covers inputs based on latest information from leading datacom equipment manufacturers. Well, this provides datacom equipment powertrain charts through 2025 to allow datacom facility designers to more accurately predict the future equipment loads and supplies ways of applying trend information of datacom facility design today. So it's a futuristic kind of a design approach the data center designers can take through this information. Now let's talk about the third book which is released by ASHRAE, the Design Considerations of Datacom Equipment Centers, ASHRAE 2009A. Well, what this book covers? This book covers the basic design considerations for data and communication equipment centers. The data facility basic selection includes the chapters on datacom design criteria, that is temperature rate of change, then relative humidity, dew point, and filtration. The HVAC load, the computer room cooling, including both air cooling as well as liquid cooling and air distribution. The section on other consideration includes the chapter on ancillary spaces such as battery plant, emergency generator room, then there is a burn-in rooms and test labs, spare part rooms, contaminations, acoustic noise emissions, structural and seismic design, and fire detection, suppression, commissioning, and availability of redundancy and energy efficiency. Well, this particular book does not cover the electrical and electronic system design and distribution. In the next book, what we are looking at is the Liquid Cooling Guidelines for Datacom Equipment Centers, second edition, ASHRAE 2013. Well, what this book covers? This book includes the definition for liquid and air cooling as they apply to datacom design, describing the various liquid loops that can exist in a building that houses a datacom space. This book also bridges the liquid cooling system by providing guidelines on interface requirement between chilled water system and technology cooling system, and outlines the requirement of liquid cooled system that attached to the electronic rack and implemented to help the datacom thermal management. Well, this is also a very important aspect. The next one is structural and vibration guidelines for datacom equipment center, that is ASHRAE 2008A. What this book covers? Well, this particular book is divided into four main sections. Part 1 gives an overview of best practices in design of datacom facilities, including recommendations for new and renovated building structures, building and infrastructures, and datacom equipment. This is covered in Part 1. Part 2 of the book covers the design of new and existing structures. Part 3 covers the structural considerations of building infrastructure, raised access flow system, and vibration sources, and their controls are discussed in detail. Part 4 covers the shock and vibration testing and seismic anchoring systems and analysis of the data equipment. Well, as far as the HVAC is concerned, this particular book is not at all required in my opinion. The next book covered is Best Practices for Datacom Facility Energy Efficiency, second edition, ASHRAE 2009B. Well, this particular book covers the many aspects of datacom facility energy efficiency, including environmental criteria, mechanical equipment and systems, economizer cycles, airflow distribution, HVAC control and energy management, then electrical distribution equipment, datacom equipment efficiency, liquid cooling, total cost of ownership, and emerging technologies. There are also appendices in this book on topics such as facility commissioning, operations, and maintenance. So this book is also very important. Let's move to another book, that is High Density Data Center Case Studies and Other Considerations, ASHRAE 2008B. The objective of this book is to provide a series of case studies of high density data centers and a range of ventilation schemes and demonstrate how load can be cooled using the number of approaches. So while this book can be very useful for designing data centers and it covers the various case studies. The next one is particulate and gaseous contamination in datacom environment, that is second edition, ASHRAE 2014A. What this book covers? This particular book describes in detail the procedures necessary to ensure airborne contamination will not be a factor determining datacom equipment reliability. This also includes a description of landmark ASHRAE gaseous contamination datacom facility survey that found that silver corrosion rate is much better predictor of corrosion related hardware failures compared to the previous practice of relying on copper corrosion rate to predict the failures. Of course, this is nowhere related to air conditioning, so you may skip particular thing because this is particularly mainly related to the racks and servers. The next book is Real-Time Energy Consumption Measurement in Data Centers, ASHRAE 2010. This particular book is designed to help bridge the gap and provides the overview of how to instrument and monitor the key power cooling subsystems. This includes the numerous examples of how to use the energy consumption data in calculating the power usage efficiencies, that is PUE. We are going to see this what is PUE in subsequent chapters. The next book is Green Tips for Data Centers, ASHRAE 2011. This book gives the data center facility owners and operators a clear understanding of energy saving opportunities. This is a very important, my friend, very important. It covers the building, mechanical, electrical systems as well as the most promising opportunities in technology. In addition, the book's organization follows the logical approach that can be used to conducting a preliminary energy assessment. The next book is PUE, a comprehensive examination of metric. It's ASHRAE 2014B. Well, it gives actionable information useful to the broad audience ranging from novice to expert in datacom equipment industry, including executives, facility planners, facility operators, datacom equipment manufacturers, HVAC manufacturers, consulting engineers, and energy audit professionals and users. The concept of PU is very fascinating. We'll see in subsequent chapters. The next one is server efficiency, metrics for computer servers and storage, ASHRAE 2015B. This particular book consolidates the information on current server and storage subsystems energy benchmark for use in selecting the appropriate IT hardware solutions. Well, this particular book is nowhere useful for HVAC, so there's no need to particularly focus on this book too much on it. The next book is IT Equipment Design Impact on Design Data Centers Solutions, ASHRAE 2016A. This particular book provides guidance in making the critical data center infrastructure equipment selection and design configuration. Next comes the standard, that is ANSI/ASHRAE standard 90.4 2016, Energy Standard for Data Centers, ASHRAE 2016B. This particular standard provides a performance-based, non-prescriptive alternative to standard 90.1 for demonstrating the compliance with minimum datacom facility efficiency in design stage. It balances the need for energy efficiency with the concurrent need for reliability in high performance datacom facilities. So again, this book is also not that critical for HVAC, you may skip it. Then comes the ANSI/ASHRAE standard 127-2012 method of testing for rating computer and data processing room unitary air conditioners. This standard establishes a uniform set of requirements for rating computers and data processing room unitary air conditioners. So of course this is a very important standard. So when you are going and buying any particular equipment or a consultant asks for the same, you may have to see that the equipment meets the requirement which is mentioned in the standard. Then comes ANSI AHRI standard 1361 SI 2017 performance rating of computer and data processing room air conditioner. Well, this is similar to what we have seen just now, but the societies are different, that is AHRI has come into picture. So otherwise the requirements are same. The last one is ANSI Basics standard 2-2014 data center design and implementation best practices. This standard from the Building Industry Consulting Service International, that is Big C, provides the requirement, guidelines and the best practices intended to use in industry. But remember, this is nowhere connected to ASHRAE. ASHRAE has just referred it. So this can be used as an addendum to what you are designing to make it even better and more fruitful. That's it. So this is what all the resources provided by ASHRAE. There is a huge pool of resources you can pull off from any one of it to make your design more better and more efficient and more acceptable to the industry. Well, let's learn more about the racks. I know for HVAC this not important, but there's no harm in learning what is rack. When you go for a meeting and there are people talking about the racks and the rows of it, you must know what is happening, right? So that will impress your client, that will impress your boss, that will impress your company. That you not only know about your HVAC, but you have certain and some of the knowledge about the racks and equipment also. So if you see what are the racks, that is the most datacom equipment are either a rack or a cabinet mounted. The vertical dimensions of this rack or cabinet are expressed in U as a U. One U, that is 1 U is equal to 44.45 millimeter of vertical height within the rack. A common height of rack is 42U. That is 42 multiplied by 44.45. Whatever is, that is the common height of a rack, almost found in the industry. Although some are the taller and some are the shorter rack, but this is, you will find 90% of the racks are of a similar height. The term rack and cabinet are often used interchangeability. That means they have to be interchangeable. A typical rack width is approximately 485 to 600 millimeters. So when people are talking about 42U or something like that, you will immediately find out what they're talking about and how many rows they're talking about, because this is what the rack expression of rack is. Now let's move on to the interfaces. Well, for air-cooled datacom equipment, the primary interface to the facility is the air inlet to the datacom equipment. On the contrary, for the liquid-cooled equipment, the interface to the facility is liquid connection to the equipment or a rack. The datacom equipment interface focuses on temperature, humidity, air quality, and coolant flow. It may be either air or liquid. Now let's discuss about the liquid cooled datacom system. Yeah, you heard it right. You might have seen that all the systems are air cooled. Everyone is talking about the air cooled system. No one talks about the liquid cooled datacom. So you might be, okay, what is this liquid cool all about? How you can use the liquid in data center? Come on, how it leaks and all the problems, right? No, don't worry, that's not a problem. This is very common trend in US and other European countries these days to use liquid cooled datacom cooling system. Now I will explore more on it and it's very interesting. You will love to hear that. Well, the increasing heat densities of modern electronics are stretching the ability to adequately cool the electronic components within the server air so far. This trend of this trend to higher recommend this air inlet temperature done with this goal of saving the energy and exacerbates the problem. Liquid cooling is therefore becoming a more prevalent. Liquid cooling is defined as a process where liquid rather than a fluid air is used to provide the heat removal, that is cooling. There are many different types of air cooled solutions for data rooms. The most common implementations are liquid cooled rack, then liquid cooled datacom equipment, and liquid cooled electronic. Now let's discuss about the liquid cooled rack. What is liquid cooled rack? The liquid cooled rack, in the liquid cooled rack, a circulated liquid provides a heat removal, that is cooling, at a rack or cabinet level for operation. For example, It includes rear door or in-rack heat exchangers that transfers the large percentage of datacom equipment waste from air to liquid. Second one is liquid cooled datacom equipment. The liquid is circulated within the datacom equipment for heat removal operation. This is more common in fact. Third one is liquid cooled electronics. The liquid is circulated directly to the electronics for cooling with no other heat transfer mechanism. So these are the three typical types of liquid cooled datacom systems. As I told you, second and third one is common, so I have not covered the first one. So I think this clarifies what exactly we meant to say that liquid cooled datacom system. From here also this diagram you can see that this is fast facility water supply and return, and the liquid goes inside and the heat exchange is happening. There is a pump here, liquid to electronics, and this is what the heat transfer is happening here. And all these pipes are running below the floor. Gone those days that water should not be used and leakage. No, this system is now very much advanced techniques are used. There are leak detectors, and this completely eliminates all ducting. This completely eliminates all the hassles related to air cooled system. No need to pump the air because everything is happening here by transferring the heat directly. So this is also a common trend these days, but not very popular, but still it is used. It's a bit expensive, but still it is being used nowadays. Contaminations in data center. Yes, this slide is all about the contaminations, and we must know all that what the contamination means in data center and what could be its hazard. The most data center facilities are well designed and geographically located in areas with relatively clean environment. Therefore, they do not have a significant contamination concern. However, the overall cleanliness of the environment is the only one consideration for location of the datacom facility, so potential contamination is often not considered to be the major driver. But there are two types of contaminants which we must know. One is particulate and other is gaseous. Some datacom facilities have harmful environment arising from the ingress of outdoor contaminations. In some very rare instances, the contamination has been generated within the datacom facility itself, but it's very rare. Now let's see one by one what is particulate contamination and what is gaseous contamination. First one is particulate matter. This often refers to the airborne solid and liquid particles. For the purpose of this slide, the term particle, particulate, aerosol, and dust are considered equivalent and represented by the term particulate matter. The size of airborne particulate matter can span a vast range of about 0.001 micron to more than 100 microns. Agencies that monitor the particulate matter from health point of view categorize the particle mass concentration as PM2.5 and PM10, representing the particles smaller than 2.5 microns and 10 microns respectively. Particulate matter may be also categorized in three size models. First is fine, second is accumulation, and third is coarse. The coarse mode is generally limited to the particles smaller than 10 microns, but can include much larger airborne fibers and particles. The particulate matter in such of these size categories may be composed of various materials from the many different sources. This particular coarse type of fiber particulate is very common in data centers, but nothing to worry, it can be easily caught by the filter which is existing in the units. But we must all know what is particulate matter. The second one is gaseous contaminants. Relevant to the IT and datacom equipment reliability, including hydrogen sulfide, sulfur dioxide, then various oxides of nitrogens, chlorine and ozone, each of which can produce the adverse effect on computer hardware. These harmful gases are byproducts of geological, biological, agricultural, industrial and manufacturing activities. They can even as low as 1 microgram per millimeter cube level. So act alone or in synergy with each other or with particulate matter to corrode the metallic materials, causing irreversible damage to circuit boards, connectors, integrated circuits, and which the other electronic components can be damaged. If datacom facilities serving the critical applications happens to be in susceptible or gaseous particulate contamination, the consequences could be devastating. As a result, it is important to address the potential of contamination and mitigate the risk as much as possible, because such factors can result in increased failure rate. The airborne dust contaminants can be detected from detailed visual inspection of the filter in air handling systems or the standalone units. The gaseous contaminants presence may require a seasonal or periodic monitoring and measurement through the use of copper and silver coupon testing in datacom rooms. The filtration system can be used in mitigate the risk of the contaminants in random datacom facilities. So while selecting the location for datacom equipment or datacom centers, this particular factors has to be considered in mind, that whether your datacom room or datacom building is located in any area where there is industries around or gas, is there any pollution around, so this can affect your data center very badly. Well, let's talk about the environmental classifications for the air-cooled equipment used for the data centers. For any piece of datacom equipment to comply with a particular environment class, in particular ASHRAE 2015A, it must be able to reliably provide its full operational capabilities over the entire allowable environmental range based on non-failure conditions. The recommended allowable ranges for each datacom equipment classes are given below. The allowable environmental ranges for 4 datacom equipment classes are here. First is class A1. The class A1 typically a datacom room with tightly controlled environmental parameters, which includes dew point, temperature, relative humidity, and mission critical operations types of products, and typically designed for the environmental are enterprises servers and storage product. This you will find very commonly. The second class is class A2, A3 and A4. These typically an information technology space with some control of environment, again the same dew point temperature, then again the relative humidity, and types of products are typically designed for this environment are volume server, storage product, personal computers and workstations. Among these three classes, A2 is the narrowest temperature and moisture requirement and A4 has the widest requirement, as you can see from this psychometric chart. But most commonly used is the A1. What we see, the data centers are mostly typically for A1. So when you are designing for data centers, you must ask your client that what is the classification is looking for, what is the requirement of data center, what is the use, what is the purpose of data center is looking for, whether it is for class A1, class A2, class A3 or class A4. But mostly you will find at class A1. But you need to ask this question, that this will impress the client, that you know what is the data center all about. So this will definitely have a big impact when you go for the meetings and all. You must ask. The recommended ranges are also given here. For typically data center, if when you say the typical range, if you see from 18 degrees, it goes to around 27 degrees, and relative humidity is also given here as close to 60% maximum. So this is what the recommended bracket it is given here, that we must follow for the data centers. Well, let's have a close look on this table. This table is very important as far as the temperatures and humidities and dew points of the various classes are concerned. In the last slide, we saw the various classes of the data centers for the air-cooled equipment. That is A1, A2, A3, A4. But there are now two more classes which we are discussing now. That is B and C. What are these types B and C? B and C are typically an home, office, and transportable environment with minimum control of environmental parameters. That is only related to temperature. And types of products typically designed for this environment are personal computers, workstations, laptops, and printers. And class C is typically a point of sale or light industrial or factory environment with weather protection, significant winter heating and ventilation. Types of products typically designed for this environment are point of sale equipment, then controllers or computers or personal digital assistants. So this we see very rarely, that is in shops and all, but uh, it's been rarely used. So for this data centers application, we can neglect the type B, class B and class C type equipment or the classification. The dry bulb, this is very again one very important point. The dry bulb temperature must be directed based on the altitude and for all the classes. What I mean to say that if the altitude is higher, definitely the dry bulb is going to be higher. So when we go for a catalog of an equipment while selecting, we must see what is the altitude, and based on that we must inform the equipment manufacturer that when you send the calculation or when you design the equipment, it must be for the this much altitude, because machines been, because as you know that altitude goes up, your air density goes down, and as the air density goes down, air requirement will go up. So definitely this is what we mean to say. When the duration we need to be do, that duration has to be happen in this way. As you could see clearly from this table, the recommended dry bulb temperatures, humidity ranges, maximum dew point, maximum elevation allowed, maximum rate of change, that is been clearly given here, and dry bulb temperature and relative humidity is being mentioned for each and every class here. Well, here if you see the recommended, that is suitable dry bulb temperatures or various ranges are being mentioned here for A1 to A4. If you see for class A1 to A4, which we have already seen that what is class A1, what is class A2, what is class A4, but we have seen that for most of the data center applications, for industrial data center applications, you may be finding only the A1. So for the A1, the recommended dry bulb temperature by ASHRAE is between 18 degrees Celsius to 27 degrees Celsius. So here humidity range also you may find that up to 60 degrees Celsius relative humidity is allowed. Then what is this dew point? What is this minus to 15, minus 9 degree to 15 degrees? What is this all about? Why the dew point is coming into picture? Well, as per the latest study conducted by the ASHRAE, it has been clearly evident that there is no significant proof has been found that the relative humidity has a direct impact with the static electricity, and it may affect the machine's no. There is no direct relation has been found between these two. So if you see here some of the things, 8% RH, it is also been allowed here, up to 8% RH to 80% RH to the maximum it has been allowed. So that has relieved the life of the designers to great extent. They do not have to be controlled or minimized. No, how come 80%? What is the basis? Consultant may ask them several questions that, yeah, what is the basis of this? No, that is not a problem. You can clearly go with the table of this ASHRAE and you can say this is what the basis it is. ASHRAE says that maximum allowable temperature is 60% with the 60% RH relative humidity, and with the dew point temperature up to 15 degrees Celsius is allowed here. So this is what. Now let's move to the classification of liquid cool equipment used for the datacom centers. Well, when we say the liquid cooled equipment, They are again classified as W1, W2, W3, W3, W4, W5. Now let's check and see one by one. For any piece of datacom equipment to comply with the particular environment class, it must be able to reliably provide its full operational capabilities over the entire classification temperature range based on non-failure conditions. What is class W1 and class W2? These are typically a data center that is traditionally cooled using chillers and cooling tower, but with an option water side economizer to improve the energy efficiency depending on the facility's operation and location. Well, this is for the very huge data center with huge load density. Then the use of chillers come into picture. But these are rarely found and only in US or some part of the Europe where you have a huge load density. Let's come to the class W3. For most locations, these data centers may be operated without chillers, although some locations require chillers. Class W4. Class W4 is the class to take the advantage of energy efficiency and to reduce capital expenses. These data centers are operated without chillers. And class W5. In these data centers, the temperature of water exiting the IT equipment is higher enough to reuse to heat local buildings, thereby increasing the energy efficiency, reducing the capital expenses with chiller-free operations and making the use of waste energy. This is for the use of class W5, that is liquid cooled equipment. The availability of datacom equipment rated for class W3 to W5 is very limited. It is anticipated that future designs in this class may be involving the trade-off between the IT cost and performance. However, these classes allow lower cost data center infrastructure in some locations. The facility, water flow rate requirement and pressure drop values of the datacom equipment may vary. Of course, these data particular are given by only the datacom equipment manufacturers, but mostly if you find the class W1 or W2 is very common, where the load density is very high. But again, as I said, you may encounter mostly an air-cooled equipment only. The availability of liquid cooled equipment for the data centers as compared to the air-cooled equipment is very rare because of the very high load of the high load or very big data centers only apply this. So for the simplicity purpose, you may check only or you may concentrate only as of now only for the air-cooled equipment. But this is an additional information, you can have it. Let's discuss the effects of humidity in data center. This is the most misunderstood topic, my friends. Now we are going to throw some light as per the ASHRAE point of view. The ASHRAE 2019 Handbook for Applications clearly states the effect of high relative humidity and low humidity, which we are going to talk about now. The effect of improper moisture control on data center operations are on twofold. One is high relative humidity, in which it has been shown to affect the failure rates of electronic equipment. The examples include the conductive, anodic failures, hygroscopic dust failures, tape media errors, excessive wear and corrosion. The recommended upper limit is already mentioned in the previous tables. That is preferably it depends on again the class A1, A2, A3, A4, then B and C. It is clearly mentioned what should be the recommended relative humidities. Now let's go to the lower relative humidity. What are the disadvantages? Well, now Please listen very carefully. Low relative humidity has been historically considered a factor in electronic device susceptibility or damage by electrostatic discharge, that is static discharge or ESD. However, the new ASHRAE research suggests that susceptibility to low relative humidity is of far less concern than once was thought. That means low relative humidity is not a concern for data center. This is based on Pomerican and Svensson study 2014, which results the recommended moisture limits have been greatly expanded in these tables, which we have shown just before this slide. The recommended lower moisture limit has been significantly reduced, as you might have seen that we have gone to 8% also in previous tables. Although the static concerns are actually related to the relative humidity, the dew point is used because it is fairly constant throughout the data center, whereas relative humidity varies widely. Because dew point can be easily monitored, dew point of an air, supply air can be easily monitored, and the return also can be easily monitored and consistently controlled. Best practice is to monitor the moisture content in data center using dew point rather than relative humidity. This is very important factor. Everyone is going to ask you this question, that why you are going for such a low humidity range. Why 8% is the range? Why not 30% static charge? Everything you can always tell your client, always say that lower humidity is not a concern here for the data centers. Lower RH is not at all affecting the machines. Higher RH, yes, they affect, but lower RH is not a concern, because for a simple reason that a recent study has been conducted and it has shown that the lower RH is not a concern and the overall RH can be monitored by dew point rather than monitor, or rather say the moisture content in air rather than relative humidity. The dew point is correct measure because it's constant throughout. Well, this particular slide is again a repetition of what we said just now, that based on the Mr. Palmerkin and Svensson study, they recommended that upper and lower moisture limits are as we have seen in the previous slides, and the static concerns are actually related to relative humidity and dew point because it is fairly constant, because as we said earlier, the relative humidity should not be considered as long as the static pressure, or sorry, the static electricity discharge is concerned. But dew point can be easily monitored and constantly and fairly controlled. The best practice is to monitor the moisture content in data centers using dew point rather than the RH, because RH can be misleading sometimes, but dew point cannot be misleading. So from the dew point we can easily calculate and found out how much is the moisture content in the air. So I think that is fairly accurate measure. Liquid cooled datacom centers are an increasing trend these days. But as I said earlier, this is only happening in case where the load is very high or density of load is very high. In that case only the liquid cool, but it is not impossible. It is very common these days. But again the question may come to your mind that, okay, what are you using water just to cool or the heat transfer within the machine? Oh, come on. That will increase the failure rate and it's too dangerous. So what are the fluids used or the liquids used to cool the datacom equipment? Well, with increasingly dense datacom equipment packaging, some components may require liquid cooling to maintain the environmental specification dictated by the manufacturer. Liquids considered for cooling electronic equipment are dielectric engineered fluid, it could be refrigerant, it could be oil. The heat transfer from liquid cooled datacom equipment or components to the datacom design facility generally take place through the Liquid to liquid heat exchangers. Some liquid cooling solutions include the immersion of datacom equipment components directly into the dielectric fluid. In either single or two-phase applications, dielectric fluid includes mineral oil and fluoroketones. These are the commonly used liquids for data center equipment cooling. There are several queries that why raised floors? Why we should have a raised floor and have a plenum below the machines or below the servers and pump the air through the plenum below. Why we should do that? What is the advantage of raised floor? Why not to directly pump the air from the top in the ducts and distribute to the machines? That's it. So what is the use and what is the advantage of raised floor? Well, see, there are several advantages of the raised floor as far as the data centers are concerned. Well, the most obvious advantage of raised floor are to provide space for permanent infrastructure such as power, piping, cabling. But these are just some of the advantages. Other advantages that it acts as a plenum for air distribution. So we can pump the air to this raised floor. The air travels within the plenum. It gets pressurized, and then the air comes out of the perforated tiles which are fixed on the data center floor, and it can be distributed based on the density of machine. That's the beauty. So based on that, we can keep the perforated tile locations near to each machine. So whether a particular machine is generating high heat, we can keep two or more tiles based on the equipment manufacturer specification of the tile or the air requirement of the particular machine. So based on that, we can distribute fairly the locations and tile type or a perforated tile type near to each machine. However, the raised access floor can add to the total mass of structure. So when we say raised floor, again it has certain weight. So when we say weight, that weight also has to be added when we design the slab below. So when, as per my experience is concerned, that weight is very minimum. So that's not a matter of concern actually. So it's actually negligible, but this is one of the factors we need to consider while designing this slab if we are considering the raised floor. And also, since all the services, say power, piping, all goes below the floor, so there is no cluttering of overhead services. So the space above the cabinets remains fairly clean. So it has an advantage. So there's no congestion above the cabinet. So any servicing happens, you can easily do above the cabinets. The best practice is to run the cables parallel to the airflow. So not in the way that it can obstruct the airflow, and to provide overhead cable pathway for ad hoc installation. And it is even better not to locate the cable in the air plenum floor space at all. The next one is CFD analysis is recommended to confirm the airflow patterns and adjust the cooling design to maximize the cooling effectiveness. If the budget allows, the CFD analysis is the best way to predict. The next is that piping, power systems or cable trays that will also occupy the space must be taken into consideration in determining the floor plenum height and effect of the airflow. It is generally accepted today that raised floor used to convey the cooling needs to be at least 600 to 760 mm high to be effective, and even higher is better because you get space below also properly to lay the cables, minimum obstruction to the airflow. The next is the perforated tiles. Perforated tiles comes in various tiles. One is 25% open, 56% open to 63% open depending on the tile specification. So it can be grade style cast aluminum tiles also. It can be legacy perforated tiles. There are various types based on requirement. Then there are directional vane type tiles. Then some tiles have an air booster fan within fitted inside. and there's the automatic airflow control also within. So these are the all modern technologies which are being commonly used when you fix these tiles and whatever airflow you need. There are various types and varieties available in the market. A good quality raised floor installation should not leak more than 2% of the air as per the ASHRAE Handbook 2019 applications. So this is also very important factor, so it should be properly tightly sealed. Let's talk about the datacom fire protections. When the datacom was there, obviously the fire protection has to be there. And when fire protection has to be there, there are certain standards which are clearly defined here. It could be this could be standard 76, standard 70, standard 72, standard 13, standard 2001 for gaseous extinguishing system, standard 750, standard 25. So these various standards of NFPA or NEC are very helpful while designing a fire protection system for data centers. These various standards give clear-cut idea how the sprinkler should be placed, what should be the extinguishing methodology, and this is worldwide adopted standards for the data centers. So if you refer any of these standards, you can clearly have an idea how data fire protection of the datacom equipment fire protection has to be done or has to be performed. Now let's discuss about the air distribution within the data centers. How it happens. Traditionally, the telecommunication spaces had no raised floor and used overhead ducted delivery, whereas datacom facility centers are used raised flooring system as a supply air plenums. There are two types of ways where the air delivery or air distribution happens. One is underfloor air delivery and second one is overhead air delivery. Within underfloor air delivery, if you see here, the underfloor delivery to cold aisles is provided and balanced using the range of airflow aisles available to 25% open to 63% open and the fan boosted, which we already know that it happens below the floor, then it comes out from the floor and then gets distributed, and again as per the law of convection, it gets heated, and as it gets heated, the air density becomes lower, and as the air density becomes lower, the air passes above and again it goes back to the unit. So this is how the underfloor delivery happens. And then within the overhead air delivery, it's exactly opposite. There is no underfloor or there is no raised floor there. It all ducted distribution happens, and again the air is again come back to the unit from front. But in our opinion and experience, that is the most impractical way. It uses your raised floor cost, but effectivity drastically goes down. Again, technically there is nothing wrong. Technically both are okay, but from operational and capex and opex point of view, underfloor delivery of the air and collection from the top is the perfect way and most optimum way to get the results and longer duration and reliability of datacom equipment. Now let's come to the most important topic of the data center. When you are designing any data center, definitely you may come across this term called as WUE, that is water usage effectiveness. Well, let's discuss what is this WUE is all about. WUE is a site-based metric developed and popularized by the Green Grid to assess the water used on site for operation of data center. It represents a comprehensive evaluation of water usage in datacom facility, where it is affected by the range of factors such as location, IT load, quality of available water source, type and efficiency of the cooling equipment, then humidification load. The formula for calculating WUE is annual water usage in liters consumed by the entire datacom facility divided by the IT equipment energy usage in kilowatt hour. So WUE is equal to annual water usage in liters divided by IT equipment energy consumed in kilowatt hour. So this is very important factor which you will need to ask or you need to consider in your proposal. What is your proposal, and that based on that you can impress client that you know what about the WUE, and this will make your site very strong in front of client. The second most important term in data center design is PUE. What is this PUE? The PUE is an efficiency metric developed and popularized by the Green Grid again. Since the concept was introduced by Mr. Rawson in 2007, the metric has been revised to make the more understandable method of reporting the measurement numbers more reliable. The PUE measures how effectively an operating datacom facility delivers energy to datacom equipment inside. I repeat, PUE measures how effectively an operating datacom facilities delivers energy to datacom equipment inside. The formula for calculating PUE is simply an energy consumed by entire datacom facility. I repeat, the energy consumed by entire datacom facility measured at meter for the facility or room. Measured at meter for facility or room divided by energy consumed by facilities datacom equipment. So PUE is equal to total facility energy divided by datacom equipment energy. Very simple. Say for example, you have a data center, you have certain energy consumed by data center equipment. Say for example, you have server racks and all stuff like that, you consume certain kilowatt hours of energy for datacom equipment. You may fix a meter there dedicated only to the datacom rooms, and you have energy consumed by rest of the other facilities. So for that definitely you will have meter. So whatever energy consumed by rest of the other total facility energy divided by datacom equipment energy is a factor for your PUE. It is important to understand that PUE metric was developed as a means for individual operations to monitor and track their own energy efficiencies. It was never intended as a means for comparing the efficiencies of different datacom centers, because too many conditions including climatic zone can affect the numbers. It is also important to understand that enterprise can take steps to reduce the total energy consumption yet achieved a worse PUE. Extensive consolidation and virtualization, for example, a purchase of Energy Star rated servers could significantly lower the datacom equipment energy numbers in the denominator of PUE equation. So it should be also recognized that PUE metric is impractical to use as a means of quantifying the projected energy efficiency in design stage of the datacom facility. So this is one very important factor which we consider from the project point of view. So when you go for a meeting, you should always put across this point that what is the expected PUE. So client will think that what the PUE means. So you can define this is what the PUE is. So definitely your chances of getting the project remains higher because your competitors may not be knowing what is PUE. So when you put across the point, you can always recommend that if you want an effective PV, you go for the better servers, high grade Energy Star servers, so you can reduce the effectiveness of an energy.
So here we come at the end of this module. Thank you very much for your patience. Thank you very much for your eagerness to learn about the data centers. Anyway, the case study is also a part of this course. You can find a live case study example which was conducted by Dhawan sir. He has given the step-by-step procedure how to arrive at the heat load of the data centers designing. So you will find it there. It's all about, and we have seen all in this course the various aspects of data centers. The data centers aspects, what we saw here is the type of data center, the classification related to air cooled and water cooled, its contaminations, then the recommended ranges of RH and the dew point, then the recommended ranges of the temperatures, why the static discharges with respect to the RH is not important, that we have saw. There's a new revelation for that. Then again, we discussed about the underfloor delivery of the air and the overhead delivery of the air, the advantages of the raised floor, then the concepts of uh, the energy efficiency also we touched upon. So these are the various important aspects we discussed. And apart from that, also if you have any more queries on data centers, feel free to write an email to us. My staff will be very happy to reply you all. Send your email to support at the rate of sbgblv.com along with your student ID or your transaction ID. So my staff will be ready to answer each of your questions. Thanks a lot and cheers.